Hi everyone, welcome back to Brookdale Farm. Today we're down at the bore getting some water. This is our small soak. It's still got a good lot of water in it for this time of year. It's got a little bit of a seep that runs in. But just around next to it here we've also got our potable water bore. We've got a small solar submersible pump down in the bore. This is the pipe coming out. It's 1 inch poly pipe. This is the power cable coming out going down to the bore, and our stainless steel cable for pulling the pump up. Now when we set this up originally, we were in a bit of a hurry, so we've got 2 solar panels that are just sitting on the ground here, and it's a little bit of a dodgy setup, and the cows keep chewing on the wiring. Last year I got as far as concreting in a steel post to hold the next solar panel. This one can swivel to face the sun. We have a lock for it down here. If we screw this up, it'll lock and hold it firm. I haven't done it up tight enough. So we're going to set up our new solar panel on this here. So this is our new solar panel that we're going to put on. I've put a couple of big heavy pieces of angle bolted across the back of it to support it, and to go onto those brackets there. Okay, so I've got the solar panel mounted up now. I use hinges on the top bit here, and this just allows me to be able to change the angle of the panel. I've got 2 braces down the bottom here, and I can change them to whatever length I want to give me a different angle. Now the ideal angle that you want for solar panels is approximately the same as your latitude. So we are about 32 degrees south here, and I think this panel's probably not quite right, but I didn't bring anything actually down to measure it. This will give us plenty of power to run our little solar pump anyway. Now the 32 degree angle is so that the sun is hitting the solar panel at 90 degrees on the at midday at the 2 equinoxes, so middle of spring and middle of autumn. In summer we want a much flatter angle because the sun is higher in the sky. In winter we actually want a much steeper angle because the sun is much lower in the sky. For this it's not going to matter. In the past I have had panels that I've changed the angles on to give me better power during summer and winter. Okay, so the next thing we need to do is mount up our on-off switch. Now whenever you're working with solar panels or DC power, direct current, it's important to use the right type of switch. If you use the normal sort of household switches that are meant for alternating current, they don't have a very big break on the contactors, and because alternating current is a sine wave power that goes up and down, it has an off point in the cycle. DC power doesn't do that. It's more like arc welding. So anybody who can weld, when you put the rod onto the piece of metal that's earthed and you strike an arc, you can then take the rod a fair way off and get an arc across that. That's what DC current works like. So you need a heavy duty contactor with a big break in the between the contacts when you're using DC. These ones are really good. There's a whole bundle of them that are available on eBay if you're doing a project like this. They're not that expensive. I have had some of the really cheap ones and I wouldn't recommend them quite so much. They're just not as nicely made, but these ones I've been really happy with. So I'm going to mount that up on our brackets now, and then we can start running some wiring. Whenever we are wiring up or doing any work on the wiring with solar panels, always remember, no matter how many circuit breakers and switches you have turned off, somewhere still has live power on it. This one doesn't matter so much because it's only 32 volts. That's enough to give you a shock, but not enough to kill you. But I had just, to make sure nothing goes wrong, I have thrown a sheet over it. This panel does have enough power to cause sparks, and today that would easily start a grass fire, and we don't want that anything to go to, we don't want to start a fire. So I have just run the wires from up the top on the junction box. I've run it through some of this protective cable here down the back. It's a bit loose because it needs to have a bit in it to be able to swing the panel around, and then it's going to come down to the switch here. Our cattle's favourite food is electrical wire, so it's always a good idea on farms, anything agricultural, to make sure you protect your wires as well as you can. It's always going to be one of your weak spots. So we're going to run this through now. I'm going to have to put the camera down to wire this up, but I'll show you how we do it in a minute. Okay, so this switch here for the solar panel actually has 4 separate contactors in it. So there's one circuit that goes through those 2 pins, one circuit that goes through those 2, one through those 2, and one through those 2. What they do with some of these, they have a bridge connector that goes in the top, so that you are joining 2 circuits together, and that gives you the ability to put twice the amperage through the switch than just one single piece. Because I'm not using a high amperage here today, I'm just going to use that one and that one. So my other cables to my pump will go in there and there. Now the wire that we use for the pump is a rubber insulated wire, and it's got quite heavy insulation on it. You can see where the cattle have been having a bit of a chew on the end of these wires. This is special cable for submersible pumps that is waterproof and is fine to use underwater. This is much heavier wire than I actually needed to get. This is just what the shop had when I went in to buy it. So we're going to wire it up with the, I think that's actually a brown wire. This is for alternating current, this wire. So for direct current, usually we use black as the earth and red as the positive. For alternating current, brown is the active and neutral is the blue wire, and the green and yellow wire is the earth wire. We're not using an earth wire because we've only got 2 wires going down to our pump, because this is all just low voltage. It is still a good idea to earth your panels. This helps when you get a lightning strike, and it means you don't burn out your pump and your controller and all of that. Anyway, we're going to wire these 2 wires up in there. I don't have any conduit to go on this piece right now, so I'm going to have to get a bit more of that, this stuff, to stop the cattle chewing on it, but it should be all right today with any luck, and I'll try and get some soon. So I'll put the camera down and connect these ones up, and I'll show you how it looks. Okay, so we've got these 2 hooked up. I found a little bit more of the protective conduit. I need to get some more still. Our black down to our blue, our red down to our almost red. Now with these switches, they are designed so that you cannot get the cover off or back on with the switch in the on position. So you always have to have the switch turned off before you can remove the cover. So I'm going to screw the cover back on and we'll see if it's going to work. Okay, now to make sure it works. So the switch is on. The pump always takes a moment to come on anyway. Yep, I can hear it running. We can just get a little bit of sound out of it. And here it is, the water running into our pod. We've just got a 1,000 litre shuttle up on the dam bank here that we keep full so that we can fill up the fire unit even if there's no sun. We did have one fire that was in the evening here. It was a little way down the road and we needed to fill up the fire unit, so this was the system we came up with just to make that a little bit easier for ourselves. Anyway, I hope you've enjoyed this video and learnt a little bit, and I hope to see you again next time. Thanks, bye.